Okay, we are starting recording. So last time we were doing exercises and we went up to exercise 6. So we went up to here. And if you remember correctly, last time we have to determine in this exercise what class is each IP address. The IP address is in binary. We don't change it to decimal, just with the beginning of the bits. We know the class of the IP address. Let's do exercise 7. So for each of the following classful networks, specify first, the total number of IP addresses. Second, the total number of valid IP addresses. Third, the network address. Fourth, the first valid IP address. Fifth, the last valid IP address. And sixth, the broadcast address. Okay, so let's take the first example. We have this network. This is a class A network. 17.0.0.0/8. So what is the total number of IP addresses in this network? So to answer this question, what do I need to know first? The number of bits that belong to the host part. For each bit that belongs to the host part, we have two possibilities. So 2 times 2 times 2 times 2 will give you 2 to the power of the number of bits that we have for the host part. So how many bits we have for the host part in this network? And how many bits we have for the host part? 8 is the number of bits for the network part. /8 is 255.0.0.0. So we have 8 bits for the network part. So if we have 8 bits for the network part, how many bits we have for the host part? 24. This will be 32 minus 8. Remember, I can break the IP address in two parts, the network part and the host part. And when I do subnetting, I will have the network part, the subnetwork part, and the host part. So we have 24 bits for the host part. So if each bit have two possibilities, how many IP address can we create in this network? Two to the power of 24, no? We have 24 bits for the host part. So how many host IP address, how many IP addresses in total? This will be 2 to the power of 24. And 2 to the power of 24, let's take the calculator to compute that. Let me use a better calculator, the scientific calculator. So 2 to the power of 24. This is this number. Let me copy it. How do I copy that? Copy, and let me paste it here. Okay, so that will be the total number of IP addresses that we have. Now they ask the number of valid IP addresses. How do we compute the number of valid IP addresses? So of all the IP addresses, we lose 2 IP addresses. The first one and the last one. So what will be the number of valid IP addresses? It will be the previous number minus 2. So it will be what? This minus 2 will be this number. So it's 2 to the 24 minus 2. Okay? Remember, we lose 2 IP addresses. So it will be 16,777,214 valid IP addresses. We will call them also host IP addresses. We will call them also usable IP addresses. Those are IP addresses that I can put in a network device. Okay, what is the network address? What is the network address? Correct. It's the first IP address of the network, 17.0.0.0. What is the broadcast address? 17.1.1.1 will be a valid IP address, not the broadcast address. So the broadcast address will be the last IP address in the network. The network IP address is the first IP address, and we lose it. So of the two IP addresses that we lose this one, and we will lose this one. So how do we get the broadcast IP address? We saw a slide that was saying how to get it. Correct. It will be 17.255.255.255. This is correct. So let me remind you how we can compute that. So let me open Paint so we can draw some graphics here. Where is the pencil? Okay, I found it. So let's make a review. The network that we have is 17.0.0.0/8. What does /8 mean? It means 255.0.0.0. In binary, it means what? 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0, dot. Dot. Oh, here we don't have a. I did a dot that is not there. Let me remove it. Okay, let me push this a little here and put it here. Zero. 0, 0, 0, 0, 0, 0, 0, 0. What does it mean? That if I write this IP address, 17, it's 0, 0, 0, 1, 0, 0, 0, 1, isn't it? Dot 0. Dot 0. Dot 0. So what can I say about this bit? It belongs to which part? The network or the host part? The first bit that is there. It belongs to the network part, isn't it? What about this one? It belongs to the network part. So what all this one mean that this one say that this bit belongs to the network part. This one say that this bit belongs to the network part. This one in the mask say that the third bit belongs to the network part. So the first 8 bits belong to the network part, isn't it? Those are the network part. Now this 0 in that these bits belong to the host part. Host part. Host, 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 host. So all the other 24 belong to the host part. So 8 bits belong to the network part, 24 bits belong to the host part. Okay. How do we get the broadcast address? What is the definition of the broadcast address? We have a slide on that. To get the broadcast address, what can we do with the host bit? What should we do? So let me put here broadcast. What should we do to get the broadcast address? We put all the 24 bits of the host part, we put them in one. Remember the network part, I cannot change them. So I keep the network bit as they are, which means I keep the 17, isn't it? Now, all the host bits in the broadcast address, we put them in one. So the 24 host bits, I put them in one. Dot 81 here. Dot 81 here. So that will be the broadcast address. So what is this number? 17, isn't it? What is this number? 255. What is this number? 255, the third byte. What is the number that is in the fourth byte? 254. So the broadcast address will be 17.255.255.255. Okay, see if they ask you what is the last valid IP address. How do we get the last valid IP address? So there is a slide that says for the host bit, you put all in one except the last one. So the 24 host bits, I will put all in one except the last one. So this first 8 in one, this other 8 in one, and 7 bits here in one, and the last bit in 0. And of course, I cannot change the network part. So I just copy the network part as it is. So this will be what? 17.255.255.254. Okay? That will be the last valid IP address. How do I get the first valid IP address? What does the slide say about the first valid IP address? So the network part, you cannot change it. We belong to the same network, so we have the same network part, which is 17. Now, to get the first valid IP address, how are we going to fill the host bit? All in 0, except the last one. So if I put all in 0, so 80 here in the second byte, 80 also in the third byte, and 70 and a 1 in the fourth byte. So if you look at this IP address is 17.0.0.1. Okay? Is it okay for everybody? So if I come back to this exercise, they ask you, what is the first valid IP address? We just show it. It's 17.00.1. It's one IP address after this one. I lose the first IP address, and the second IP address will be the first valid IP address. So one IP address after 17,000 is 17,001. And what is the last valid IP address? Is one IP address before this one. So one IP address before 17.255.255.255 will be 17.255.255.254. Okay? Is it okay? So this is the answer. Let's do the second exercise. We can go to binary, but if we go to binary, we lose more time. We can do it directly in decimal. We can get used to it and do it directly in decimal. So in the last one, in the second row, we have this network, 200.7.8.0/24. So they ask us, how many IP address in total we have in this network? So what is the first step to answer this question? We need to determine how many bits belong to the host part. So how many bits belong to the host part? 8 bits, correct. 24 bits belong to the network part, and 32 minus 24 is 8. So 8 bits belong to the host part. Each bit of the host part have two possible values, 0 and 1. So for each bit, I have two possible values. So 2 times 2 times 2 times 2, 8 times, will give me 2 to the power of 8. What is this value? 256 IP addresses. So in this network, in total, we have 256 IP addresses. Of course, we will go from .0 to .255. Okay? So here they ask you, how many of those 256 IP addresses are valid IP addresses? So this question is very easy to answer because we already have the total number of IP addresses. So how many will be of those total IP addresses? How many are valid? 254, because we will lose the first IP address and the last IP address. So 254, 2 to the power of 8 minus 2. Now, what will be the network address? The first IP address of this network will be what? And what will be the first one? Of course, it will be 200.7.8.0. Okay, the 27.8.7.8, I cannot change it. All the IP addresses in this network will have in common 200.7.8. Why can I say that? Because 207.8.7.8, 200.7.8 belong to the network part. The first 24 bits belong to the network part. So I cannot change this 200.7.8. All the IP addresses in this network will start with 200.7.8. They will start like that. So I am free only in the last byte, because in the last byte we have 8 bits that belong to the host part. So what will be the first valid IP address? It will be one IP address after this one. What is one IP address after this one? Of course, it will be 200.7.8.1. What will be the broadcast address? Correct. 200.7.8.255. Of course, look, we have 256 IP addresses. They go from .0 to .255. What will be the last valid IP address? So it will be one IP address before this one. What is one IP address before this one? What is the IP address that can be before 200.7.8.255? Exactly, it will be 200.7.8.254, correct. And look, here we say we have 254 valid IP addresses. Count the IP addresses that go from here to here. From .1 to .254. How many valid IP addresses you have? 254. Because we lose this one, and we lose this one. Now, from this number, this IP address, to this IP address, we have 256 IP addresses in total. Since we lose the first IP address and the last IP address, valid IP address go from .1 up to .254. So .1, .2, .3, .4, blah, 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 blah. .253 and .254 are valid IP addresses, which means that I can put them in any networking device that I need to configure. Okay? So let me go to the binary notation, and we will see that we find the same thing. But we will try to avoid to go to the binary notation because it takes too much time. Okay? So let me erase this exercise and start a brand new one. So the network that they give me is 200.7.8.04/24. So let's put 200 in binary first. 200 is 128 plus 72, isn't it? And 72 is 64 plus 18, isn't it? And 18 is 16 plus 2. So 200 will be 1, 1 for the 64, 0 for the 32, 1 for the 16, 0 for the 8, 0 for the 4, 1 for the 2, and 0 for the 1. This is 200 in binary, isn't it? Let me just verify it because nobody say yes. I want to be sure we work with something that is correct. So 200 in binary is C8. So this is not 200. 200 in binary is C8. It must be 1100 1000. So it's not correct. Huh. So 200 is 128. 128 plus 64 will be what? 192. Oh, 192 plus 8. That's correct. Nobody say anything. So it's 192 plus 8. So it was incorrect, thanks to God. I did doubt about what I was writing. So if I put it in binary, it will be 128 is there, 64 is there, 32 is not there, 16 is not there, 8 is there, 4 is not there, 2 is not there, 1 is not there. So it will be C8 in binary. Okay, this is 200. So let me put this IP address in binary. So 200 .7 So 7 is 4 plus 2 plus 1. Dot 8. So 8 is just 8, no? Dot 0. Okay. So what can I say? Which of those 32 bits belong to the network part? The first 24. So this is a network bit, network bit. So you see, it's long to do in binary. It's why we cannot keep binary for a long time, and we need to get used to see that fast in decimal, no? So all those 24 bits belong to the network part. And those are host bit, host bit, host bit, host bit, host, 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 host. How do we get the first valid IP address? The first valid. So we cannot change this 24. What we can change is here. So to get the first valid, let me copy them as they are. So the first byte will always be 200. The second byte will always be 7. The third byte in this network will always be 8. So where can I change it? In the fourth byte, because we have host bits. So to get the first valid IP address, how do I fill the host bit? All in 0 except the last bit. So I have 7 bits, all of them in 0, except the last bit. So this will be 200.7.8.1. This is the first valid IP address. How do we get the last valid IP address? So we cannot change this 24. So I'm just going to copy them as they are. So first 200, then 7, cannot change this 7, then 8, I cannot change this 8. So if I want the last valid, the host bit, I'm free to do whatever I want with them. So to get the last valid, what should I do? I put all of them in 1 except the last one. Okay, we have a slide on that, and we saw that already. So I put all of them in 1 except the last one. So this will be what? The last valid. 200.7.8, and what is this number? 254. And how we get the broadcast address? So we cannot change the first 24. So I keep the 200 as it is. I cannot change it. I keep the 7 as it is. I cannot change it. I keep the 8 as it is. I cannot change it. Now in the host part, I do whatever I want. So to get the broadcast address, we fill all the host bit in 1. So if I fill all of them in 1, what is this number? 255. So we come back to what we say here. The broadcast address is 207.8.255. The last valid IP address, how do we get this 254? Here there are 8 bits. I put 7 of them in 1, and the very last one in 0. How do we get this one? Here we have 8 bits for the host part. So we put 7 of them in 0 and the last one in 1. How do I get this 0 here? all the host bits have to be in 0. When all the host bits are in 0, I get the network address. So let me show you again the slides that we saw. So we saw these slides, no? I don't remember if it was here or it was in the previous slide. So here we say the same thing, but there is no slide, so it was in the previous. We do the same thing, but it was in the previous one. So let me show you. Okay. How do we get the network address? We put all the bits in the host portion in 0. So how did we get the first host IP address? In the host portion, we put all the bits in 0, except for the very last one. How we get the last valid IP address? In the host portion, we put all the bits in 1, except the very last one. How we get the broadcast address? In the host part, we put all the bits in 1. So we do have a slide that say that, no? Okay. Okay, let's go back to the exercise. Let's do this one. So this is a class B network. How do I know that it's a class B network? Because the first byte, 133, is between 128 and 191. For example, this was a class A because the first byte is between 0 and 127. This was a class C because the first byte is between 192 and 223. So this is a class B. And the default mask for a class B is /16, which make that the first 16 bits belong to the network part, and the remaining 60 bits belong to the host part. So this /24 say that the first 24 bits belong to the network part, and the last 8 bits belong to the host part. This /8 say that the first 8 bits belong to the network part, and the remaining 24 bits belong to the host part. Okay, so this is a /16. The separation between the network part and the host part is done here, between the second and third byte. So the first question is, what is the total number of IP addresses? So before we answer that, how many host bits we have? 16. We have 16 network bits. So these 16 say we have 16 network bits. And 32 minus 16 give also 16. So we have also 16 host bits. If we have 16 host bits and each host bit have 2 possibilities, it can be either 0 or 1. How many different IP address I can do in this network? 2 to the power of 16, which is, let's ask our calculator to do that. So let me go to the scientific calculator. 2 to the power of 16 is 65,536. So 65,536 IP addresses. Okay. Okay. Of all those IP addresses, I will lose 2. So how many valid IP addresses I will have? Exactly. 65,534. So what will be the network address? So the first 2 bytes, I cannot change them. All the IP address that belong to this network have to start with 133.44. So all the IP address that I will write in this row have to start with 133.44. Now, the last 2 bytes are free for me to do whatever I want. So of course, the network address is the first IP address. So if you are free here and here, what will be the first IP address? What do you do with X and Y? If you want the very first IP address, 00. The first IP address, no? 00. So we put them both in 0. That will be the first IP address. So, which means that we put the 16 bits in 0. Now, the first valid IP address will start, obviously, like that. Now here we have 16 bits for the host part. If we want the first valid IP address of this 16 bit, what should I do? 15 in 0 and the very last one in 1. So if you have 000000000 dot 00000001 in decimal, that will be what? 0.1, isn't it? That will be 0.1. Of course, it's one IP address after this one. One IP address after 133.44.0.0 is 133.44.0.1. Now, the broadcast address, I have to start with 133.44. Now, the remaining 16 bits, if I want the broadcast address, what should I do with them? All to 1. So if you have 1111 dot 1111 what will be the last 2 bytes? 55.255. So the last valid IP address, the one IP address before this one, it will be this. Now, if I go to binary, it have to start with 133.44. Now, for the last 16 bit, what should I do for the last valid? I put 15 in 1 and the very last one in 0. So I put 1111 1111 dot 1111 1110. And this will be 255.254, isn't it? So it's very fast. You should see it very fast. Okay, let me do some exercise on something that I'm kind of surprised that when I ask what is the next IP address, you think so much. If I give you this IP address, 10.0.255.0, what will be the next IP address after this one? What will be the one that follow? Of course, it will be 10.0.255.1. What will be the previous one, the one that is before this one? Very good, 254.255. Of course. Okay, if I have this IP address 10.255.255.255, what is the IP address that is before this one? Before it will be what? 255, correct. 255, yes. 254, correct. This is the one that is before. What is the one that is after? Isn't it? Remember that each byte can go up to 255. So when you add up 1 to 255, it becomes 256. So you have to put 0 and there is a carry that go there. It's like, for example, it is 11:59 minutes, 59 seconds. If you add 1 second, this will become 60. You cannot have 60, so you put 0 and you have a carry. So this 59 plus 1 will become also 60. You cannot put 60. So you put 0 and you have a carry. So 1 second after 11:59 minutes 59 seconds will be 12 0 minutes 0 second. Because here the number go from 0 to 55. Here the number go from 0 to 55. Here the number go from 0 to 255. So after 255 we have 0. But we have to carry a carry to the next byte. Okay? Let's do another one. What will be if I take, for example, I take 10, 7, let me put 10 to 55, 0, 0. What is the next one? It will be 10 to 55, 0, 1. Okay? What is the previous one? The one that was before 10 to 55, 0, 0 is what? 10 to 54 to 55 to 55, isn't it? Add 1 to this number. If I add 1 here, I will get 256. So 256, I have to put 0 and there is a carry. Okay, 255 plus 1, it will be 256. I cannot put 256. So I'm going to put 0 and there is a carry. 255 plus 1 is 254 plus 1 is 255. And 10 is 10. So if I add one IP address to this one, I arrive to this one. Okay? Let's do another exercise to see if you understand things. Let's say that I have this IP address. 10.7.8.200. And I want to add 100 to this. So 100 IP address after, it will be what? So 200 plus 100 is how much? So 200 plus 100 is 300, isn't it? So what should I do? 300 is what? 256 plus 44, isn't it? So here I'm going to put 44, and there is a carry of 1. So 1 plus 8 is 9, and the rest does not change. Do you see that? So 100 IP address after this IP address is this IP address. It's like, for example, it is 11, let's say 25, 55. And you want to add 20 seconds. So you do what? 55 plus 20 seconds is what? 75. And 75 is 1 minute plus 15 seconds. So the result will be 15 seconds here. And because of 1 minute here, 1 plus 25 is 26. So 20 seconds after this time is 11, 26, 15. So the base that we use here is base 60. But the base that we use here is base 255. When we reach 255, we have to, when we pass 256, we have to have a carry. Okay? So next IP address or previous IP address, you should see it. Okay, so we have this exercise. So this exercise is a /24. So how many bits belong to the host part? 8 bit, no? So the number of valid IP address, the number of total IP address will be 256. How many valid? 254. What will be the network address? This address. So look, of the 32 bits of the IP address, how many belong to the network part? 24, which means that all those bits belong to the network part, isn't it? The first 24. And I have 8 bits in the host part. So I manage these 8 bits. So what will be the broadcast address? Correct. It will be 218.5.0.255. Be careful here, don't put 255. You cannot put 255 here. Why? Because the first 24 bits, I cannot change them, which means the first 3 bytes. There will be, the first 3 bytes will be equal in all the IP address of this network. So they will all start with 218.5.0, where I can change things in the last byte. So one IP address before this one will be what? So it will be 218.5.0.254, one IP address before. One IP address after this one will be what? 218.501. So remember, only one byte, the last byte, which is 8 bits in total, I can change them as I want. So the first valid IP address of the 8-bit that I can change, 7 will be in 0. And the very last one will be in 1. For the last valid IP address, we have 8 bits here. I will put 7 in 1 and the very last one in 0. It's give me 254. Okay? Let's do this one. This is a /16. Does that mean what? These 2 bytes belong to the network portion. These 2 bytes belong to the host portion. So I cannot change the first 2 bytes, but I do whatever I want with the last 2 bytes. So how many IP addresses in total we have? 2 to the power of 16. How many are valid? 2 to the power of 16 minus 2. So what is the network address? So the first 2 bytes, I have to always have them. Because here it says the first 16 bits are common because they belong to the network part. So I cannot change the first 2 bytes. So I will always have 190.7. Now, if I want the very first IP address, what will be the last 2 bytes? 0, 0. If I want the very last IP address, and I'm free to change the last 2 bytes, what should I put in the last 2 bytes to get the very last IP address of the network? All 1 in binary, which means in decimal it will be 255, 255. Now that you have, if you have the network address and the broadcast address, the first valid is very easy to get because it's 1 IP address after this one. So 1 IP address after this one is this one. And the last valid IP address is very easy to get. Is 1 IP address before the broadcast address, which will be 190.7.255.254. Okay? If I go to this one, this is a class C. Why it's a class C? Because the first byte is between 192 and 223. So, of course, the default mask of a class C is a /24. The separation is here between the 3rd byte and the 4th byte. So all those bits, or all these 3 bytes, cannot change. So all the IP address will have to start with this. I am only free in the last byte, no? So it have to start with 194.0.0 and something. So this will be the very first IP address. So what should I put in X to have the very first IP address? 0. This will be the very last IP address. So remember that X can go from 0 to 255. So if I want the very last, what should be X? 255, correct. So this will be 1 IP address after this one. This will be 1 IP address before this one. So before 255, we have 254. So of course, no, it's a /24. I can just copy that here. Look at this one. The first byte is between 0 and 127. So it's a class A. In a class A, the default mask is /8. The separation is here. It means that I cannot change the first byte. So I will have always 102. I am free here, I am free here, and I am free here. So the last 3 bytes, I can manage them as I want. So if I ask you here, what should I put in X, Y, and Z to get the very first IP address? 0, 0, 0. Okay? This will be the very first IP address. 0, 0, 0, which means that the 24 bits that are dedicated to the host part, I put all of them in 0. Now, how do I get the very last IP address? All X, Y, and Z, I put them in 255, which means that the last 24 bits, since I'm doing a broadcast address, I put all of them in 1. So this will be 255, 255, 255. Now, 1 IP address before the broadcast address will be what? 255, 255, 254. Here, 1 IP address after 102.0.0.0 will be what? 102.0.0.1. Okay? Now, if I take this case, This 188 is between what and what? Between 128 and 191. So it's a class B. What is the mask of a class B by default? /16, which means that the first 16 bits, I cannot change them. So here, we will always have 188, 0, whatever you want, whatever you want. Okay? If I ask you the broadcast address, how will you change X and Y to have the last IP address? You put 255 for X and 255 for Y. So, which is the larger IP address that I have, 255 and 255, which means that the last 16 bits, I put all of them in one. Now here we have 16 bits. If we put 15 in one and the very last in 0, what will be X and what will be Y? Of course, it will be 255.254 because it's one IP address before 255.255. So here it will be 255.254. And here, one IP address after 180.0.0 will be 180.0.0.0 will be 180.0.0.1. And of course here we have that 180.0.0.0, no? Okay, we need to go faster on that. We cannot spend from now on a lot of time to see what is the broadcast address or what is the network address. We need to find them very fast, okay? So, exercise 8. For each of the following IP address, specify first, the class full network this address is part of, and second, what is the type of IP address? If it is a network address, a valid address, or a broadcast address. So look at this IP address. This IP address is which class? A, B, or C? It's B. Why? The first byte, which is 177, is between 128 and 191. So it's B. So what is the default mask of a B? It's /8, /16, or /24. /16, which means that I cannot change those, isn't it? The first 2 bytes. So we already say that this is class B. So if I ask you, this IP address belongs to which network? What will be your answer? So I'm asking, what is the network address associated? This IP address belongs to a network. What is the network? (177.6.0.0). Okay, it belongs to the network 177.6.0.0. So I cannot change those 16 bits. I'm free to change the last 16 bits. If I want the network address, is the first IP address. So how do I get the first IP address? I put the last 2 bytes in 0. If I ask you, what is the broadcast address associated with the IP? Well, this IP address belongs to a network. And we say that the network is, let me write the network here, will be 177.6.0.0/16. So this IP address belongs to this network, isn't it? So what will be the broadcast address of this network? Correct. It will be 177.6.255.255. If I ask you the first valid IP address of this network. Correct, 177.6.0.1. If I ask you the last valid IP address. Correct, 177.6.255.254. So this IP address, they ask you what type of IP address it is. Is it the network address? No, because the network address is 177.6.0.0. Is it the broadcast address? No, because the broadcast address is 177.6.255.255. So this IP address, what it is? It's a valid IP address. We have how many valid IP addresses in this network? 2 to the 16 minus 2, a bunch of them. Any IP address that don't end with 00 or 255.255 is a valid IP address. So of course, this one have 1190, so it's a valid IP address. So it will be a valid IP address, which means that I can put this IP address in a device, in a network device, okay? Let's do this one. I have this IP address. This IP address belongs to a class A network, a class B network, or a class C network. Class A, why? The first byte is between 0 and 127. So if it's a class A, what is the default mask of a class A? /8. What will be the network address? Correct, it will be 12.0.0.0. So this IP address belongs to the network 12.0.0.0, which means I cannot change the first byte. All the other 3 bytes as I want. So if I want the network address, which is the first IP address, I put the last 3 bytes in 0. What will be the broadcast address of this network? Correct, it will be 12.255.255.255, correct. So this IP address is what? This 12.3.255.255. Is this a broadcast address? Is this the broadcast address? There is only one broadcast address. Is it the broadcast address? Is it the network address? Or it is one of the valid IP address? It is a valid IP address. It's one of the many that we have, okay? Which means that this IP address, I can put it in a device. Okay, let's see this example. What class this IP address belong to? Class A, class B, or class C? Class B. Why? Before the first byte, which is 130, is between 128 and 191. So what is the default mask? Class B is /16, no? Class A, /8. Class B, /16. Class C, /24 by default, okay? Unless we change it. So it's a /16. What does it mean? That the first 16 bit belong to the network part. So which byte will be always the same in this network? The first 2 bytes, which is 130.9. They cannot change. So this IP address belongs to which network? 130.9, I cannot change them. Now, the X and the Y, if I want the network address, it have to be the very first IP address. How do I get the very first IP address? What should I do with X and Y? 0. So it belongs to this network. So the IP address that you gave me here, is it a valid IP address? So if it is not a valid IP address, it can be either the network address or the broadcast address. So what it is the network address. Correct. This is the network address. Okay. This is the network address, which is the very first IP address of the network. Can I put this IP address to a networking device? No. Okay, we cannot put the first and we cannot put the last. We lose them. They are not valid. So you cannot configure a networking device with this IP address. Now, if I ask you, what is the broadcast address associated with this network? It will be what? So the first 2 bytes, I cannot change them. So it have to start with 130.9. Now I'm free with the last 2 bytes. So the broadcast address is the very last IP address. So what should I do with the last 2 bytes? I put them in 255. So the broadcast address will be 130.9.255.255. Okay? What about this case? What class this IP address belong to? A, B, or C? C, because the first byte, which is 205, is between 192 and 223. So this is an IP address that belongs to a class C network. It belongs to a class C network. Okay, we have many class C network. So which class C network it will be? And by the way, if I am a class C network, my net mask will be /24, which is 255.255.255.0. And if it's a /24, it means that all the IP addresses that belong to this network will have in common the first 24 bits. If they have in common the first 24 bits, all of them will start with 205.14.56. So if I ask you what is the network address, so the 205 you cannot change it, the 14 you cannot change it, the 56 you cannot change it, and the last byte, the very last byte, you do whatever you want. So what should I put for X if I want the very first IP address? I put 0. So that will be the network address. What is the broadcast address of this network? Exactly. So it will be the first 3 bytes, I cannot change them. But the last byte, I'm free. So I'm going to change the last byte to 255. So it will be 205.14.56.255. So this IP address, which is in this network, will be what? A valid IP address, a network address, the network address, or the broadcast address? It will be the broadcast address. Okay, I can put the in front because there is only one. The broadcast address. By the way, I should have right here also the, because there is only The network address, no? Let's take this example. This IP address is class A, class B, or class C? A. The first byte, 44, is between 0 and 127. It's class A. So the net mask by default is going to be 255.0.0.0, which is /8, which means I cannot change this byte. And I'm free to change as I want the last 3 bytes. So what will be the network address? What should I do here with X, Y, and Z if I want the very first IP address of the network? Correct. So the network address will be 44.0.0.0. What will be the broadcast address? So the broadcast address is the very last one. If I want the very last one, what should I do with X, Y, and Z? Exactly, I change X, Y, and Z with 255. So let me put, that will be the network address. So at the end, this IP address, it is what? It is the broadcast address for the network. Okay? There is only one broadcast address in the network. It is the broadcast address. Look at this one. It's end with 00. Is it a network address? Is it the network address? It's a valid IP address, correct. Why? To be the network address, we will need a 0 here also. Because this part belongs to the network part. These 3 bytes belong to the host part. So if I want the network address, I have to put them 000. If I want the broadcast address, I have to put them 255, 255, 255. Okay? So this is a valid IP address. One of all of them, no? We have many valid IP addresses. This will be a valid IP address. So this is class A, and the network is 16.0.0.0/8. I can write, if I want, 255.0.0.0. No? It's another way to write the network. So a network is 2 things: the network address and the net mask. Okay? With that, you know everything. You know what is the broadcast address, you know what is the first valid, the last valid. So, how do I go from here to here? Another way to see it. So look, let me show you another way to see it. So I'm going to take the IP address is 177.6.11.19. What is the net mask? This is a class B. Since it is class B, the net mask is 4/26. And 4/26 in decimal, in the dotted decimal notation, will be 255, 255.0.0. So to get the network address associated, I want to get this 177.6.0.0. The operation that you need to know is a bitwise AND. So you can put that in binary, but you are going to lose your time. So if I have a byte, any byte, and I do a bitwise AND with 255, what will be the result? You take a byte and you a bitwise AND with 255. It will be B. Exactly, you don't change it. Let's see an example. You have this value. You do a bitwise AND with 255. 255 is 81. When I do a bitwise AND with 1, I don't change the value. So 0 and 1 will be 0. So I keep the 0. 0 and 1 will be 0. 0 and 1 will be 0. 1 and 1 will be 1. So I keep this 1. 1 and 1 will be 1. 1 and 1 will be 1. 0 and 1 will be 0. And 1 and 1 will be 1. So look, this is the same B. B and 255 will be B. So for example here, 177 bitwise and 255 will be what? Exactly, 177. 6 bitwise and 255 will be what? I don't change it. It will be B. It will be 6. Now, B a byte bitwise and 0 will be what? Correct. So here, whatever you have bitwise and 0 will be 0. Whatever you have bitwise and 0 will be 0. So look at this IP address. Look at what we wrote here. So to get the network address, you can bitwise on the IP address that they give you with the net mask. Let's do a second example. Let's do the one that is here. So I have 12.3.255.255. What is the net mask? /8. So 255.0.0.0. When I bitwise AND a byte with 255, what is the result? The same byte. I don't change it, so it will be 12. When I bitwise AND a byte with 0, what will be the result? 0. When I bitwise AND a byte, whatever value you have, on 0, 0. I bitwise AND a byte on 0, the result is 0. Look at, we find the 12,000 using bitwise AND. Let's do this example. 130.9.0.0. It's a /16, so I have to bitwise AND with 255, 255, 0, 0. So when you take this number, whatever number, and you bitwise AND with 255, it will be the original number. So this 130 here. I bitwise AND with 255 again, so I maintain the 9. I bitwise AND with 0. It will be 0 no matter what you put here. I bitwise AND with 0. It will be 0. So we did find that the network address is this one. You see? So for example, if we take this one, let's take this one to see again. Let me clean this. So we have 44, or let me give you any other one. 732.85. What class is this one? A. So I have to bitwise AND with /8. And /8 is this. So whatever you take bitwise on 255 will stay as it is. Whatever you have bitwise on 0 will be 0. You bitwise a byte with 0, result is 0. you bitwise a byte with 0, result is 0. And it's normal because look at the separation is here. If the separation is here, I maintain the left part and I put in 0 the right part. Okay, and this gives me the network address, which is the very first IP address of the network, no? Okay. Which of the following net masks are valid? Is this a valid net mask? So what is the definition of a net mask? A series of 1 followed by a series of 0. The total number of bits must be 32. So let's see that. Do we have a series of 1 followed by a series of 0? We have 8 1, 24 0. So it's a valid net mask. Remember where we have 1, it says that this bit belongs to the network part. Where we have 0, it says the corresponding 24 bits, which are the last 3 bytes, belong to the host part. Is this the second one? Is this one a valid mask? No. Because here we have a series of 0, then a series of 1. No. It has to be a series of 1, then a series of 0. Is this a valid network mask? Yes or no? How many? Do you have a series of 1 followed by a series of 0? Yes. What is 224? 1 1 1 0 0 0 0 0. So how many 1 we have here? 19. 19 1. How many 0? 8 plus 5. 13 0. Isn't it? Because 224 is 1 1 1 0 0 0 0 0. Okay. Is this a valid network mask? No. Why? Because we have a series of 1, series of 0, series of 1, series of 0. Okay? It's not a valid. So let me show you in binary. This is 255. So we have 255, 192, 255, 0. So in binary it will be 81 for the 255. Then it will be 21 and 60. Then it will be 81 and 80. So 81 and 80. So as you can see, we don't have series of 1 followed by series of 0. Okay? Because we have a series of 1, good, we start well. Then we have a series of 0. We cannot come back to a series of 1. Okay? So this is not a valid net mask. Is this a valid net mask? Yes, it is. Why? The series of 1 is empty. So the series of 1 have 0 1 and is followed by a series of 0 that have 32 zeros. So it's a valid one. Is this a valid net mask? Yes, it is. How many one we have? 31, followed by 20. Because 252 is 1111, 1100. So we have 31 followed by 20. Is this a valid net mask? No, because in the first byte we already have problem. Because what is 10? 0, 0, 0, 0, 1, 0, 1, 0. So we start with a series of 0, then we go to 1. No. If we need to start with a series of 1. This series of 1 can be empty and following by with a series of 0. Is this a valid net mask? No, because the 4 is 0, 0, 0, 0, 0, 1, 0, 0. So we have series of 1, series of 0, a 1, and series of 0. Okay, is this a valid net mask? Correct. We have a series of 1, which have 32, 1, and a series of 0, which is empty. So this is a valid net mask. All the bits belong to the network portion. Here, all the bits belong to the host portion. Okay? This is the difference. Okay. Exercise 10. Convert the following net mask from the side R notation, which is the / notation, to the dotted decimal notation. So / 24 will be what? 255.255.255.0. / 28 will be what? So it's 24.1 plus 4.1. So 255, 255, 255. And the last byte will be 1111 0000. What is this value? 240. So with time, you will memorize this table. So 0, 0. 128 are just 1. 192 have 2 1. 224 have 3 1 inside. 240 have 4 1 inside. 248 have 5 1 inside. 252 have 6 1 inside. 254 have 7 1 inside, and 255 at 8 1 inside, which means that 0, if I represent it in binary, doesn't have 1 inside. 128 just have 1 1 inside. 192 have 2 1 inside. 224 have 3 1 inside. 240 have 4 1 inside. 248 have 5 1 inside. 252 have 6 1. 254 have 7 1. And 255 have 8 1 inside. So when the example that we were seeing is / 28. So / 28 is 24 plus 4. So 24, 55 is 8. 255 is another 8, isn't it? Then a third 255 is another 8. So up to now, I have 24. I'm missing 4 here, so I need 240. So /28 will be 255, 255, 255, 240. Is it okay? If I take the next example, /4, it will be what? 240,000. So /4 will be 240, which are 41000. Let's see another example before we leave. So /13. So 13 is what? Is 8 plus 5, isn't it? And 5 is what? 248. So it will be 248, 0, 0, isn't it? Which means that it has 13 1 inside. So 8 1 plus 5 1. If you put it in binary. Okay? For 1/23, this one, for example. How do you create for 1/23? For 1/23 will be what? 255, give me 8. Another 255, give me another 8. So we have 16. How many is missing? 7. 7 is 254. Isn't it? It's 8 plus 8 plus 7. It will be 4/23. 4/30 here, for example. If I do 4/30. So 30 is what? 8 plus 8 1 plus 8 1. Up to now I have 24. How many is missing? 6. So it's 252. If I need 6 1, which 1 1 1 1 1 1 0 0, 252. So you must be very fast from converting from the side R notation to the dotted decimal notation. This notation, we also call it the forward slash notation. Okay? Or the prefix length notation. Okay, thank you so much for staying. I see you in 2 days.